So let's look at some more real-world scenarios. You should have already completed the Desmos lessons, and now you're going to apply just some context here to be able to write the function and then figure out the value of the x. So let's look at number one. The original value of a painting is $9,000, and the value increases by 7% each year. Find the painting's value in 15 years, and then find in what year will the painting be worth $50,000. So we have a few things going on here. Let's first look at the initial formula for a growth, exponential growth. We know it's growth because it's increasing instead of decreasing. So this is the formula f of x equals, and then we have our initial rate, a, so that's the starting value, and then we're going to multiply that times 1 whole or 100% plus whatever other percent, the growth factor, is the 100% of the amount plus the growth rate that it's happening at, and then that's being taken to the power of x. So let's put this into some context in here. So we have f of x equals initial value, 9,000, times 1, because you have 100% of it, plus you have 7% because it's increasing. So plus 7/100 to the power of x. So here's our general function. Now we're going to find the painting's value in 15 years. So this is going to be our input. So our x represents our years. So we want to know the function of 15 years, so we replace that. Now this is just saying our output. This is just what this is going to equal. And then we have our function. Now notice we can just combine these in here. So this becomes 1 7/100. 100% of the price of the painting plus 7% is how much it's raising each year. And x being our years, so really we're going to replace this with 15. X is here, x is here. So now we're just going to do some work on the calculator. Now if you're using your phone, you're going to want to turn it this way, right, to get it to where you have your functions the way you need them. So first you're going to do your base number to the power of 15. So we need our x to the y button, 15. So that's how much it is, 15 years, but we got to multiply that times the original value of 9,000. So it's going to be f of 15, and we're going to round it, so we're going to use this approximation equal sign, is going to be about 24,831, and this rounds to 28 cents, so I'm going to leave it at 28 cents. So that's the first thing we needed to do. The next thing is to figure out what year, so what x value will the painting be worth 50,000. So now we're finding that we want our complete output to be $50,000. So actually, let's rewrite this. 50,000. That's our f of x is our complete output. 50,000. We know it's 9,000 to start, and it raises by 7% a year, so we add that to the full percent, the full amount plus 7% to the power of x. Now let's look about what we just got. We just got about half of 50,000 at 15 years. So our method now, because we're solving for x, is we're going to use the guess and check method. So we have 1 7/100 to the power of, I don't know, let's try 20. Multiply that by 9, and we're getting closer. So we may want to do 30 and then multiply that by your initial amount, and now it's too much. So we know it's going to be in between 20 and 30. Let's try 25. And we're getting much closer. It says, what year will the painting be worth? So maybe it's 26 years. It's a little too much on in both directions. So let's think about what would make sense. We're going to say, it says what year. Probably want to round it to the whole year. So we can say in about 25 years, but less than 26 years. So we know it's going to be in between there. And we could come up with a specific value. We could keep going and do 25.2, 25.3, and just keep trying that. But it's just saying in what year. It's going to be in between the 25th and 26th year. And that's okay. We used our approximation. Well, we didn't use it here. We used it up there, so that's fine. Okay. Let's do exponential decay. I know that because it's decreasing. The rate is 3% per year. In 2000, there were 1,700 people. Find the population in 2012. So automatically I'm thinking this is 12 years time, right? So the population of a town is decreasing. What's the starting point? Well, the starting point in 2000, we're going to go with that, is 1,700. So f of x equals, now let's first recall our initial formula. Instead of it being a growth, it's going to be a decay. It's decreasing. So the only thing we're changing is we're taking this full amount that we start with, but we're going to subtract the rate at what in which it's decreasing. It's decreasing at 3% per year. So we have our full amount minus the 3% for each year taken to the year exponent. Now we're going to figure out what is f of 12. What is after 12 years? How many people are there? Oh, we forgot to put our initial value in here. That's okay. We'll replace it. So we have 1,700 times 1 minus 3% to the power of x, but x is 12. So we're going to compute that in the calculator. So 17, nope, just kidding. 1 minus, well, think about what that means. 100% minus 3%. Well, actually, let's rewrite this then. This is the same as finding just 93, no, 90, oh my goodness, I'm having a hard time today. 97%. If you take away 3% from 100, it's 97%. Okay. 97% to the power of 12 times 1,700. We get 1,179. You can't have partial people, right? So we're going to round this. And you can't round up from half a person. So how many total people do you have? You just have 1,179. I don't know what happened there. So at 12 years, you would have 1,179 people in the population. Now, the original formula calls for the opposite of this, right? You're going to take your whole percentage of the amount, the initial value, and you're going to add for a growth, the growth rate. In a decay, when it's decreasing a percent every year or so, you're going to subtract the rate. And so that's when we decided we combined, we did what was in parentheses first here and shortened it out to an equal expression. So this is the same as 1 7/100. This is the same as 97/100 because it's just 97%. Take that to your exponent and then multiply it times your initial value. And it should make sense that you have a number smaller than your initial value because it's a decrease, it's a decay. Over here, it should make sense that you have a number larger than your initial value because it's a growth, it's an increase. So you're going to use these examples as well as everything you've learned in the Desmos activities to help you complete this page. This needs to be turned in by the next time you're in class, so either Friday or Monday, but Friday's the test, so you should have it done before then. You will have a couple problems on your test that are like this. The next thing I want you to do before we leave this video is you need to cross off number 4. You're not doing number 4 because we do not need to do compound interest this school year. So the rest of them should just be exponential growth or decay. You're going to finish these 3, keep on studying, and hopefully do amazing on the test.